When it comes to that of network analysis and two-port network, very important parameters from the two-port network is Z parameters and Y parameters. Starting from the two-port network itself, the two-port network looks like this: one pair of input terminals and another pair of output terminals, where we have I1 over here and V1, output port I2 and V2. Usually we start this analysis from the two describing equations for Z parameters and Y parameters. The two describing equations are like assuming voltage as independent parameters and current as dependent. What we have is V1 is equal to Z11 I1 plus Z12 I2. Alright, so this is equation 1, where we start the analysis from describing equations for the two-port network, Z parameter describing equations for the two-port network. And second one is V2 equal to Z21 I1 plus Z22 I2. So usually in electrical circuits, what happens is, if you want to evaluate the input impedance, output current is made 0. And when we want to evaluate the output impedance, input current is made 0, vice versa, like that. So in that case, this will be the I1 being the input current and I2 being the output current. So individually making it 0, will be able to evaluate a pair of Z parameters. For supposing if I1 equal to 0 and I2 equal to 0 on either side, what we have is, with I1 equal to 0, in the sense input open, when input side is open, I1 will be 0, and so what we have, we will be left with V1, which is equal to Z12 I2, right, from which we have Z12 will be equal to V1 by I2. Alright, and with the same from the second equation, with the same I1 equal to 0, when I1 equal to 0, we will have, what is that, V2 by I2 will be equal to Z22 straight away. This will be V1, this will be the resultant, and the Z parameter which we are in search of will be the ratio V2 by I2. Alright, and in the same way, making I2 equal to 0, in the sense open side, when considering the open, output side and opening it away, that makes I2 equal to 0. And when I2 equal to 0 in this expression, what do we have? It's this result gives, this approach gives Z11, which is equal to V1 by I1 over here. This will be 0. When output is open, I2 will be 0, and so we will be left with this one, and we will be in search of this Z11, which is the ratio between V1 and I1. And from the second equation, it's Z21 will be equal to this one. This will be 0. So this will be Z21 will be equal to V2 by I1. So these are the 4 Z parameters. 4 Z parameters over here: Z11, Z12, alright, Z21 and Z22. These are the 4 Z parameters. And for the same two-port network, we have this one. What is this ratio? It's a voltage by current. It's a voltage by current, so impedance. So at some point we'll have to evaluate the admittance also, which is the reciprocal of this one, and then comes the need of exercising on Y parameters. Alright, so from the same network, and two describing equation for the Y parameters are, what is that? I1 equal to Y11 V1 plus Y12 V2. Alright, and the second one, I2 equal to Y21 V1 plus Y22 V2. Right. So once again, current over this side, while evaluating impedance, we'll have to focus on making, we have to make current 0, and when we evaluate admittance, the reciprocal, we'll have to make voltage to be 0. In the sense, in this expression 1 and 2, we have expression 1 and 2, making V2 equal to 0 gives us a set of admittance parameters, and making V1 equal to 0 will give us another set of admittance parameters. So when V1 is equal to 0 and V2 equal to 0, in the sense, when input is short circuited, we have some output admittance something. Alright, and when output is short circuited, making output voltage 0, V2 equal to 0, we'll have some input admittances. So if V1 equal to 0 from both expressions, when V1 is equal to 0, we'll have from first one I1 by V2, which is equal to Y12, because this will be V1 short circuiting the input makes V1 equal to 0, and so this will be the resultant from the first expression. And from the second one, we'll have with V1 equal to 0, isn't it? So this will be left over in the sense I2 by V2, which is equal to Y22. This will be the second one. Alright, and on the other hand, when V2 is made 0, so these two, this will be made 0 when output is short circuited. This will be made 0, so we'll be left with Y11, which is equal to I1 by V1, and at the same time Y21 will be equal to I2 by V1, if I'm not wrong. Yes, of course. Once again, see, check I by V, I by V, I by V, and I by V. So all are admittance parameters reciprocal to the impedance. Alright, so this is not all. Actually, the more important point is establishing a relationship between deriving an expression for Z parameters in terms of Y parameters. Alright, so this is the important point over here. Once again, it's expressing Z parameters in terms of Y parameters. So the procedure is, we start with the two describing equations for Y parameter, and then we compare with the standard expression for Z parameters. Alright, when we have to establish a relationship or deriving expression for Z parameters in terms of Y parameters, we start with the Y parameters and some reduction, and finally we'll be reaching some equation which no more reduction takes place, and at that point we compare with the Z parameters. Remember this one, expressing Z parameters in terms of Y parameters. We started with Y parameters, so this one. Alright, so considering these two describing equations for a two-port network of its Y parameters, this one. So let it be equation 1 again, and let it be equation 2. This could be, these two equations could be represented in matrix form. How that is written? I1 and I2. Alright, so which is equal to Y11, Y12, Y21, and Y22. Close the bracket. Square matrix, and once again a column matrix, V1 and V2. Right, so in that case, the delta of where can I have that reading here? The delta of this one will be equal to what it is, this into this minus this into this, Y11 into Y22 minus Y12 into Y21. So we during this derivation or analysis, this one del, remember this one, this comes again and again, we have to plug in somewhere else. Alright, so this is the del. So in order to have V1 according to Kramer's rule, in maths we have that rule, isn't it? The best approach to evaluate unknown x1, y1, x2, y2, like that. So in this, if you have to evaluate V1, what do we need is del 1 by del. Right, del is already here. This is the value for del. This is the expression for del. And guys, I need this place. Alright. What we have to do is, now it's time to find out del 1, which helps us in finding that V1 from this expression. Alright, so how to find out del 1? Del 1 is given as del 1 is given as the determinant of this one, plugging in this one. Alright, according to Kramer's rule, first del 1, so this I1 and I2 over here, plug in. So how it comes? I1, I2, and Y12, Y22, that will be as it is. Alright, so the determinant, okay, this should be the determinant, not this one. This should be the determinant as we have evaluated del. So this gives us what it is, Y22 times I1 minus Y12 times I2. This will be the expression for del 1. Alright, so guys, this one also, I'll be in need of this. And so how to evaluate V1? This del 1 by del gives us the expression for V1. So V1 v1 is equal to once again del 1 by del, which is equal to, what is del 1 here? This entire one, alright. So y22 I1 minus y12 I2, alright, by del. What is this del over here? This one, del, right? The del appears over here, del, and del over here. So this is the expression for v1, and comparing this expression with the standard expression for z parameters, what do we have? See, very much similar. v1, I1 and I1, and I2 and I2. So what do we have? This ratio is this one, comparing this expression with the first expression, and this will be this. All right, so that's the point over here. And so guys, this is the one. So z parameter in terms of y parameter, what it is? It's a z11 is equal to y22 by del, y22 by del, right? And z12 in terms of y parameters, it's negative y12 by del. So that is, we have another two set of z parameters. So how to evaluate that? That like having del 2, calculating del 2, v2 will be equal to del 2 by del. Anyway, we have that del. So calculating del 2, it's like this. The procedure is this one, y11, y21 as it is from this matrix, and plugging in I1 and I2 in the second column. What do we have? I1 and I2 over here. And now once again, this is the determinant, all right, not the matrix, but evaluating the determinant of this one gives del 2. It's a y11 I2, this into this, minus y21 into I1. All right, that's for del 2. So what do we have? v2 can be evaluated making use of that ratio, del 2 by del, which is equal to that one. So what do we have? Del 2, it's a y11 I2 minus y21. So let's write it in order, all right. So negative y21 I1 plus y11 I2 by del. Very much similar. Once again, comparing this expression v2 equal to this with the standard expression for the describing equations for z parameters, we have v2, I1, I2. So this will be the resultant. All right. So I'm erasing this one to give the comparison over here. z21 will be the negative of y21 by del, this one. All right. So what is that? z21 is will be equal to negative of y21 by del, and z22 that will be which one? z22, this will be y11 by del. All right. So these are the 4 z parameters expressed in terms of y parameters. Is this? Yeah, this is all right. z22, and did I go wrong? Negative. We have negative over here. That's it, guys. z21, z11, z22, and z12. On the other hand, it will be asked to go for the reverse engineering. It will be asked to derive the expression for evaluate y parameters in terms of z parameters, right? And after this one, it won't stop. Like this will lead to ABCD parameters, and very much important for the exam point of view is it will be asked to establish relationship between ABCD parameters, derive expression for ABCD parameters in terms of z and y parameters. So you need to have a idea on this one if you have to go for ABCD parameters. And once again, writing that expressions, y parameters, we have describing expressions I1 is equal to y11 v1 plus y12 v2. The second expression is I2, which is equal to y21 v1 plus y22 v2. Alright, so in order to express admittance parameters in terms of impedance parameters, we have to start from impedance parameters and do some reduction and compare with this one again. The same procedure which we have done just now for Z2Y. So what do we have for Z parameters? Straight away the matrix form. Alright, so it's a V1 V2, it's this, which is equal to Z11 Z12 Z21 and Z22, this, and I1 and I2 column matrix. Right, so once again, what will be the delta? What will be the del, the determinant of this one? It's a this into this, isn't it? Z11 Z22 minus Z12 Z21. This will be the del. Right, and on the other hand, if we want to have I1, we need to evaluate del 1, which is like this one. So plugging in this one, column matrix V1 and V2 from here, and Z12 Z22 from this one, the determinant. This will give us del 1. Alright, so this into this, in the sense Z22 V1 minus Z12 V2. Alright, so that will be if we want to have I1, we need to have del 1 by del, isn't it? Okay, this is only for del 1. So from making use of these two values, expressions, we can evaluate for I1, isn't it? So I1 is the ratio between del 1 by del. Alright, let me write over this side. So see, I1 will be equal to, what is del 1? Guys, this one, this is del 1, which is Z22 V1 Z22. Alright, don't get confused, it's a Z22 V1 minus Z12 V2 by del. So by del and by del. What is del? This is our del from the main matrix. Alright, so comparing this expression with the first expression for the from the describing equations for y parameters, it's a I1 and V1 over here. So this will be equal to this Z22 by del, that will be equal to Y11. Let me write over that side. Alright, so here with the red, what is that? Y11, that will be equal to Z22 by del, Z22 by del. Alright, in the same way, Y12, this will be equal to this, the negative times Z12 by del. What is this? It's a Y12, which is equal to negative of Z12 by del. Alright, so we need to evaluate another set of y parameters, making use of once again Cramer's rule. So evaluating del 2 will help us to find out I2 and comparing this one. Alright, so del 2, what is that procedure? Once again this one, considering that matrix Z11 Z21, and in order to evaluate del 2 according to Cramer's rule, we have to plug in this column matrix into the second place. So it's a V1 and V2 over here, and the determinant of this one will give us something del 2. Alright, so what is this? V2 Z11 V2 positive over here minus this one, isn't it? Minus Z21 V1. Alright, which is equal to minus this into this, we have positive, minus this into this, isn't it? So I have written in that way, like in order. Alright, so this is for del 2. So how to evaluate I2? The ratio del 2 by del gives us I2. What it is? Del 2 is this one, negative of Z21 V1 plus Z11 V2 by del, entire by del by del. All right, so this is for I2. So simply comparing this expression with this one. What do we have? It's y21 is this, all right, and y22 it's this. So this is the this is how we express y parameters in terms of what is that? It's a y21 will be equal to negative z21 by del, all right, and the same way y22, y parameters in terms of z parameter, it's z11 by del. So what is that del over here? The cross multiplication, the determinant of the main matrix. All right, so hope you understood. Thanks for watching.